Now let's go here. Okay. So these are the slides. That's what they look like. So this talks about some interesting thoughts about the technical underpinnings of open source, how it came about, some of the philosophical bases on which it was built. And we'll talk about those a little bit, but for more understanding and more background, I really do. This is a really good book, The Cathedral and the Bazaar. I read this back in 2007 or so, and I still love going through and rereading some of the sections. It talks about how if you worked on software prior to 1997 or something like that, or maybe even later, you'd use something called the waterfall method of design. And what you tried to do was you tried to interview the user, or the U.S. Army, or all the possible users of Twitter, and you would try to figure out just what the software was supposed to do, and then you would write requirements that were supposed to capture that at a functional level, or at a conceptual level, and then you would write detailed requirements that were supposed to reduce those kind of functional, vague concepts into concrete things that the software had to do to be successful. And then you would go through and you would pseudocode out your use some design tool to kind of come up with a concept of how the system was supposed to work together, and then you would start coding everything, and then after a few iterations of that, you would start testing it, and then you would show it to the user, and the user would say, that doesn't do anything like what I wanted it to do. Or it's completely unusable, or a number of different concepts. And that was kind of the cathedral, right? When you're building a cathedral, you have to plan ahead. You have to do really great things. And by the way, I say that it didn't work. We sent people to the moon with that, right? I mean, that was the model that put people on the moon. It was the model that generated the space shuttle. It is workable, but it's complex and it's difficult, and it resulted in a lot of failed software projects because going in, the user didn't necessarily understand what it was they wanted to build, or the builder didn't necessarily understand what the user was trying to tell them. All sorts of reasons why this is a very difficult way of doing things. Or some of these things just failed because the project took 5 years, and by the time 5 years had elapsed, well, the problem had changed. So it's a very overhead high, very upfront commitment way of doing things. We used to talk about, and I think this is actually still true no matter what the development model, but 80% of the cost of the code is not, only 20% of the cost of the code is actually writing code. The other 80% is not. And it's that other 80% that kind of drives all the other stuff. So what the Cathedral and the Bazaar talks about is something that first arose in open source software, where you couldn't have all this great planning because you didn't have a dedicated team. What you had was a bunch of volunteers who were willing to get together and work, but they're volunteers. So you have to keep them interested. You have to keep them working on, you have to encourage them to work on your projects. And that's where both the Cathedral and the Bazaar and free software kind of pick up. They kind of tell you about this culture where instead of building something big and owning something, you kind of turn it free and allow a lot of different people to contribute, and you talk to the users and you get continuous feedback. And you can get continuous feedback because what you're developing exists out there in the open, and anyone is open to look at it and pick it up and kind of try to work with it. So this is free culture. I'm finding this harder and harder to find. This was written by Laura Lessig. Among other things, this talks a little bit about some abuses, at least what Lawrence considers abuses. I think he's probably right, of the intellectual property process and of federal regulation to stifle innovation, something that isn't possible or is less possible in an open environment. So anyway, those are two really interesting and important readings. I highly recommend you go through them. And I'm going to give you kind of a highlight of what they say, but it's not going to be by any means exhaustive. And I'm recommending 1, 2, 3, 4, and 9 of the Cathedral and the Bazaar. But the whole book is good. You should read the whole thing. And in chapter 4, by the way, RPI actually shows up here. So RPI is, if you remember, the whole, I think this is the one, the whole record companies getting together and banding together to come out against file sharing. You probably remember like Pirate Bay and all those websites where you could illegally share your music. RPI got caught up in that. One of the students at RPI actually did something that wasn't nearly as subversive as a lot of things. He just basically went out and looked for software or made a catalog of what people had on their shared drives. And since some people had shared music, he ended up in a lot of trouble when the RCIA, the record companies, sued him and claimed that he was violating their copyrights. So that's one of the themes of this is the difference between open and closed systems. This is I'm almost certain that this was written by Professor Ibanez. I knew him fairly well, and this is his way of talking. So the question we want to ask is why would we want to do open source? Because basically, when you're doing open source, what you're doing is you're taking your intellectual property, the stuff you created, and you're saying, you know what? I don't care if you use it. You're welcome to use my stuff, and you're encouraged to use my stuff. And there's always some kind of licensing terms, and the licensing terms for open source software are very liberal. So basically, you're essentially giving away something that may or may not have value. And the question is, why would you possibly give away something that may or may not have value, that may have value or may have a lot of value? Well, a better question is, why would you want to lock it up? And that's kind of where this why not open source comes in. And by the way, we're going to talk about a lot of things. You're going to hear free software. You're going to hear open source software. This is probably even more important reading. We'll get into this a little bit more, but this is a good definition of what open source software is and what free software is. I'm going to talk about a lot of this in subsequent lectures, but free software was coined by Richard Stallman. And it has to abide by these 4 freedoms. And Richard Stallman had a very specific philosophical and political bent. And he wanted this to be viral. So the GPL is an example of free software. And it abides by these freedoms, and it also limits your ability to not abide by these freedoms if you're using their software. It's called a restrictive or viral or a copyleft license. An open source license can be a lot more liberal in terms of permissiveness, allowing people to do a lot more with your code. And instead of, and here's Cathedral in the Bar again, instead of having the 4 freedoms, it has the 10 principles of the open source definition, free distribution, source code, derived works, all the way down to 10. Again, we'll get into those a little bit more. The key is that things can be open but not free, but if they're free, they're also open. So free software is slightly more restrictive than open source software. I'm not really aware of any big projects that are not open that are free. But the idea is there is some, since the 4 principles aren't exactly the 10 principles, there's a little bit of ability to walk through there, and we'll get into that a little bit more when we talk about licensing and such. But this is a really good, another really good piece of, and it's only a couple pages, a page or so. So walk through that, and we'll talk about it a little bit as we go through this course. So why open source? Well, the first thing is, you'll find out in Arcos, and you'll find out a little bit here, is that one of the major goals of open source software, or one of the major advantages of open source software, is you're not dealing with trade secrets. You're not dealing with privacy issues. You have to maintain HIPAA and other privacy laws. But in general, everything that's being done is being done in the open, including the community activities. So it's fun. You can form communities. A lot of people do this as a hobby. They're not getting paid. They're just contributing to open source software because they either they're enticed by the community, or they want a specific outcome on a piece of software, and they have the ability to do it because it's open source. It's also very good for learning experiences. A lot of communities are very open to novices and trying to help people bring people up to speed on specific technologies that they use, because that makes them more powerful in the end. All open and free source, all open and free software has a clause in it, both of them, that allow you to, just by the way they're stated, that allow you to make money off the software. Red Hat, for example, and Cygnus Solutions, Red Hat in particular, right? They were acquired by IBM for $4 billion. What Red Hat largely does, or largely started out doing, they've expanded their scope quite a bit. But basically what they did was they took a free piece of software, put it on a disk so it was easy to install, put a cool logo on it, shrink wrapped it, and sent it out. And they got paid $40 a copy. That is an oversimplification, but that's essentially what Red Hat did. And then they provided support. And then they guaranteed that all the software they shipped on that disk worked together. And they tested it. And over time, they became worth $4 billion. Very big open source solution. Cygnus, right? Commercial support for free software. That's kind of the other model. The idea here is that, you're, and by the way, this is the same model that Kitware kind of uses. I should start opening new windows instead of that Kitware uses. The idea here is that you have free software, but you build stuff that uses it, and you build stuff for other people that use it, or you provide training, or you provide other support. And Cygnus and Kitware kind of work with that model. Kitware does a lot of government business, where they have these nice, very powerful libraries of toolkits, and they get hired by the government to leverage these toolkits to solve problems, such as some of the stuff that I worked on was, or other businesses, by the way. We worked for a number of drug companies. I was involved with detecting and quantifying the extent of cancers, both in the lungs and in the brain and in the colons, using these software toolkits. And companies trying to do drug trials were with an imaging endpoint, where they were going to determine the success or failure of their drug based on imaging, would hire us to take and write them code to analyze their images so that they could determine, is the brain tumor shrinking? Is it growing? Is it better or worse? How many lung nodules are you finding in smokers with 10 pack years? Those types of questions. And the code, they didn't have the expertise. Investing in the expertise was going to cost them a lot more than hiring us for 6 months to do the job for them. And so we could roll some more money back into our open source toolkits to make them even more powerful. And because we were the ones largely developing and using them, we had the ability to do consulting on them to get money. There's Kitware's front page. and people were more than willing to pay for that. And then in the end, the beauty of it was if they didn't like what we produced, or if we got too expensive, or if we tried to jack up our prices, it was an open solution. And they could go, all the tools we used were open, and they could go elsewhere. So they had this guarantee of not having vendor lock-in. People have a lot of different motivations. Open source is the side of sweetness and light. I will maintain that. So if you're an altruist, if you want to save the planet, if the world improves, you improve. Really good motivation for doing open source. Open science and engineering. If you've ever, I used to go to conferences where we were looking at lung cancer, and a new graduate student would stand up and say, we have this really awesome algorithm for detecting lung cancer, and it's 100%. It detects every lung cancer in all of the examples. And we would ask, how many examples did you run it on? And they would say somewhere between 5 and 20. And that is way below statistical significance. And if you're using an AI algorithm, artificial intelligence, you haven't even had enough data to train it. So basically, you've overtrained to just always recognize your 5 or 20 lung cancers. Open data is a big thing. And there are a lot of open data since that time. There are more and more open data repositories for things like CT lung cancers. You're going to talk a lot about medical in this kind of setting because it's the stuff that I did a lot of research in earlier. You can get, if you want, you can get CT scans with contrast of the colons. You can also get visual camera recordings of the actual procedures. If you've seen some of the horror films with like a mouse, or a giant worm, or a snake with a round head, kind of going through a bunch of goo after the heroine or the hero. That's a lot what colon procedures look like. Those are all, more and more those are publicly available. A lot of them are publicly available from the NIH, from the National Institutes of Health, or from the National Cancer Institute. It's one of the schools underneath it. If you have access to all of this, if you have access to data and you have access to the source code and you're willing to collaborate, that's going to actually make science go a lot faster. You'll notice now that we have all these data sources, now that Google is collecting data on pretty much everything, AI has really kind of come into its own. Not necessarily because the algorithms are that much better, although I will admit that they've done a really good job at packaging up some of these neural nets and things, but because there's data available and you don't have to, you have sufficient data to both train and test, and then test in the real world. So that's enabled by openness in data and in source code. And this is kind of a philosophical one. Intellectual freedom. There's a thought that data yearns to be free. An idea isn't something you can contain. It yearns to be out there. It's not like making a new widget, right? A new widget, well, okay, it's easy to encapsulate and quantify and sell. But an idea, right? How do you patent an idea? And how can you say that somebody doesn't have the right to use a thought? And that's kind of the idea of this intellectual freedom concept. It's data isn't the same as a thing. I'm not poorer because you took my idea. Now, I might be poorer if I could have convinced you to buy it off me instead. But there's nothing removed from me when you take that idea and run with it. And that's kind of this idea of intellectual freedom in patenting code and things like that. And do I have that? Here we go. And kind of to defend against that, by the way, you can get things like nerd merit badges. I got this. I don't even remember what the disclosure was. But one of the ways to stop patents is to disclose the ideas behind them before somebody else does and patents it. So I wrote up a couple of disclosures for the, I think it was I can't remember. they were associated with the Free Software Foundation. So that's kind of the idea is data knowledge yearns to be free, and we're not made any poorer by sharing our knowledge. So therefore, you should share it, and that's just a philosophical bent. It's having an impact on all sorts of areas. I worked a lot in the medicine thing. I worked with a guy who was doing an open outside of the federal government. He was doing an open compilation of lung cancer data. It was to get around HIPAA, people had to upload their own scans. But once they did, the data was made open to everybody. We can dig that up if anybody's interested in looking at it. We have people who are working on chemical compounds. There's a lot of open source. Avogadro, I think, is the pronunciation of it. It's an open source molecule viewer synthesizer that tries to look at the bonds in chemical compounds. All open source, all openly available. And these things go into effectiveness of treatment, right? If the data is out there and the data is open, you're doing a study on lung cancer. I'm doing a study on lung cancer. We don't have to both do our data collection. And I can take your algorithm and run your open algorithm against my data and compare it heads up against a working copy of my algorithm. And we can do a real comparison instead of me trying to go through your papers and glean out enough information to actually replicate your work. And then, have I done it correctly? Did I do all the tricks that made yours fast? Did I implement it badly so that my stuff would look better? All of that goes out the window when you can just share data and share algorithms. And finally, we get into scalable software development. By using the methods of open source, gets you more into the agile way of looking at things with the cathedral and the bazaar. The bazaar is a chaotic thing where everybody's going off and working on their own thing. But in the end, it's a very efficient way of selling stuff. And it's the same kind of concept with this distributed design. It forces you, for one, instead of having a big cathedral that you're building, you build a lot of small little things. And that means that all of those small little things, as long as you maintain the APIs, are replaceable. And since the user is there and the user's, he's walking through the bazaar, you can get feedback much more quickly. And that's when we work on our projects. Like I said, we're not going to hold you to a formal design methodology, but we will try to push some of these ways of communicating and some of these ways of dividing up the project, and things like, get a minimum viable product, just something, anything that works, and then build on that to make it better. But get the framework in place first. Don't spend a lot of money getting the framework in place, because money being time, resources. Because until you have that in place, you don't actually know if it's solving the problem or not. So it's a pretty effective way of doing development. Okay, there are some reasons not to do open source. If you want to own the idea, if you think that this is the idea that's going to let you retire, then you probably don't want to release it. And I will tell you that the ideas that retire you are not as common as you think. And even with something like Facebook or Google, right, they had some really good ideas. It took them a long time, and there was a lot of sharing that went on before they got there. So be realistic in evaluating your idea. A bazaar is chaotic. And if you can't take the chaos in the development for various reasons, you probably don't want to be in open source. You may want to use open source software, use maybe a few versions back. Don't be on the bleeding edge. But you probably don't want to be developing your thing open source. And the reason is that a lot of the open source things are either volunteer-based, which means that I am enticing you to work for me. And as soon as that enticement goes away, as soon as you get bored, you decide to take a trip to Hawaii instead, well, then, I have nothing to hold over you to force you to come back and contribute. So it is all volunteer. It's more of a trying to encourage and convince and build up a community than it is something where you can say, I've paid you X number of dollars, come in and do this. It's distributed, so if you have to, if it's something that has to be controlled and local, it's not really suited for that. And then in a lot of cases, there's no clear authority. We will talk about things like blessed repositories, specifically next week, where there is somebody who declares this comes into this version with it, lieutenants and things like that. But the problem is who actually owns the open source code, right? If I download all of Linux, right, I just do a clone, right? It's allowed by the licensing. I can put in whatever I want. I can't claim it's the same version. I have to give it, I have to be honest. But they can't stop me from putting it in, and they can't stop me from selling it in, competition, for example, with a regular Ubuntu or other Linux distribution. So, it gets muddy, and forks, as a last resort, when there's a dispute in the community, you can always fork and walk away. And, it's something you have to keep in mind is there's not necessarily a winner in those cases. How many of you have installed the latest, not this latest, but have installed a latest Mac version and everything goes wrong and nothing works? Or you upgraded your version of Windows and things just go bad, and you find out that what they did was they completely deprecated an API that you were depending on in your code. And all of a sudden, none of the code you have actually works anymore. That's when you have control, right? If you can control things, then you can do things like change the APIs. Or more likely, you can force people, you can publish a public API, and you can force people to code to that public API. And then anything that's not coded to that public API is fair game. Well, what happens if within that public API, if that public API, all the dirty little stuff behind it is available? Well, when that's the case, then people can look inside that public API and they can build off of stuff that you didn't intend. And open source projects change their APIs. They do change their code, but it's a much harder consideration because, again, you're dealing a lot of times with volunteers. And if you break something, what's to stop them from walking away or going back to a previous version and forking at that point? So it's a lot more considerations that, if you want absolute control of your software and how it's used, it's really hard to do that with an open source software. Most of the benefits for open source software, or a lot of the benefits for open source software, scale with the number of people who are actually using it. If I make something open and I'm the only person working on it and no one wants to use it and no one wants to work on it, I'm not really getting any benefit from the open source, right? No one else is augmenting me. What I get is what I put in. But if I have 100 people doing it and 100, and 10 of them are working actively or 15 of them are working actively, then for every unit of effort I put in, I get 14 back or 99 back, depending on how many active users we have. And then I'm getting a benefit. So if I'm doing open source for me and there's no thought of bringing other people in, then there's really not much of a benefit to it. And all the overhead with dealing with doing things in a way that's community friendly is relatively wasted. Selling stuff is well known. The whole concept of I give you X, you give me money, or I give you X and you give me 3 chickens and a cow. That's all well understood. It's a very, it's been the basis of economics for a long time. We know how to do it. We know how to do it well. A lot of these, even the Red Hat model is not all that well understood, right? Trying to replicate that model for something else is not all that well understood. And some models, like doing consulting off a base of open source software, it's not clear what the scalability of that is. At what point have you saturated the market? How many people can you bring in? How big can your company grow if it's doing imaging software, for example, for government and commercial customers? I can say that it can scale over 120 people. I know that for a fact. But can it go to the size of an Amazon? I don't know. So if you own the stuff and everybody wants the stuff, you can demand more money, and that's really one of what that is saying, and that's the end of it. Okay. I kind of talked about this already, but we'll just state it again. Cathedral, structured development, it's controlled. Generally, one company or one person controls it. They build it, and then they release it to the world after they've gone through whatever testing they want. Bazaar model, the Linux world, the open source world, tends to be a lot of contributions and hopefully a lot of users. And the users can pull down contributions periodically so that it progresses and you can get continuous feedback. It's a much tighter customer developer loop. Release early and released often. That's how you get commits, by the way. Don't release stuff that's obviously broken. If you need to push it, put it on a branch. But once you get it working, put it out there and let whoever's going to decide whether it gets into the code base, whether it's a blessed system or a shared system, collaborative system, get it into the system and let people try it and make a judgment. And then do that before you've invested a lot of resources and a lot of time in making it perfect and dotting the I's and crossing the T's. From the Cathedral and the Bazaar, particularly when you're dealing with volunteers, any good piece of software has to start by being useful to somebody. And when you're starting to develop this, if you want to get volunteers, making it useful to the people you want to attract as volunteers is very important. You guys generally we have 2 or 3 or 4 game projects every semester. Surprisingly, though, we'll have 1 or 2 on Bitcoins or non-monetary currencies, digital currencies. We'll have a bunch on trying to learn or trying to apply artificial intelligence, just different things that you guys all find interesting, and they result in projects, and hopefully they result in you guys going out and after you graduate, getting great jobs in those areas because of everything you've learned and everything you've developed. One of the big enemies of open source software, is the NIH. And I don't mean the National Institutes of Health. Not invented here syndrome. People like to start from scratch. They like the idea that they can do everything. They like the idea that their solution is going to be far better than anybody else's. And probably, I'm very willing to cede that. The problem is that if you try to do everything, then you have to do everything, right? And things get big awfully fast. What you'll find out when you're doing your projects is that you're going to come to me with some milestones, and depending on how much feedback I give you, you'll come to me with your milestones on week 1, and you'll be behind by week 3. Because things are hard. Write the stuff that needs to be written. Borrow, steal appropriately with open source licenses. Stuff that works for the stuff that you don't have to write. Don't be afraid to use somebody else's project. Don't be afraid to write a framework that cobbles together 7 of them and call it beautiful. This is the one I like. If you are doing your first project in Arcos the first semester, I can guarantee that within, if you continue it, within 2 or 3 semesters, you will rewrite it. Because you learn more from doing the first version than you will ever learn or ever be able to plan. That's part of what goes back to this problem with the cathedral model. You've set up everything right at the front. You know your structure. You know what things are going to do. You know what capabilities you're going to have. And then changing it becomes increasingly hard because you don't get the feedback you don't have the opportunity to feed things back in a tight loop. It's much heavier of a structure to move when you need to change your stuff. If you If you release early and release often, you can go with the flow. If you lost 2 weeks of work, well, that's not good, but it's much better than losing 2 years of work. So get the stuff in people's hands, develop it fast, and plan to throw one away because you will learn more implementing it the first time. The second implementation will take a fraction of the time of the first implementation just because that's the way it works. You learn so much more. You learn so much by doing the first version that it becomes much easier. And you need to do that before it gets so complicated that you can no longer grasp all the details and you have to start from scratch. Interesting problems start by finding something that's interesting. I think that's kind of a tautology almost. And if you just keep looking and you keep your mind open and you're willing to explore and compromise and talk, be part of the community, you'll find something to do. Generally, there is more going on out in the world than can possibly be done. So it's not, you are the premium. The jobs are things that you can do. And again, release early, release often, listen to your customers. If you can get your customers involved in the process, right? That's kind of like getting something free, like the little prize in the bottom of the Cracker Jack. As soon as they start participating with you in the development, it's going to speed up your development, and it's going to make your program better because you'll tighten up. Again, you're trying to talk about release early and release often is all about doing a tight development loop. If they're working with you, and they're testing and they're willing to put up, you've given them enough value that when you blow it and you give them something that's buggy, they're willing to live with it, or provide you feedback and how to fix it. That's a very valuable contribution. And this final one is something that we run into. I imagine that most of you don't want to be at RPI forever. Maybe I'm wrong. If you're doing a project, if you're doing an open source project at Arcos or here, or just in general even, here is particularly telling because you're all going to leave within a few years. You have 4-5 years here in general. If you've created a successful project like Yaks, like Shuttle Tracker, Submiti is mentored by Professor Cutler, so she's here long term. But when you lose interest, and some people stay interested, for a year or so after they graduate, when you lose interest, your last duty is to hand it off to a competent successor. And I want you to look for that in the file in the mail program example in the readings we gave you, because that's part of what happens in that example. Find a way to hand it off. Find somebody to leave it in a state that it can be picked up. If you can't find somebody to pick it to take it off and it's widely used, leave it in a state that somebody else can pick it up, and leave and help them out, and be willing to turn over the reins. By the way, that's happening in Python right now as well. The originators of Python are stepping away, and it still seems to be going pretty strong. Okay, this is the many eyes statement. If you have a lot of people working on something, finding a problem and solving a problem are not necessarily the same thing. So having a lot of people able to characterize problems and then turn the characterization over to people who have the competencies to fix them, right? That's two very valuable skills. So the many eyes is exactly this. I find something, maybe it's out of my particular expertise or in a piece of the code that I don't know, but I can characterize it. If I can get enough people to look at it, somebody's going to be able to solve it. This was Linus Torvalds' many eyes quote, essentially. We're all brilliant, or every one of you, right? One of the things you want to be sure of is that you don't use your brilliance as an excuse to make code that can't be read. Make your data structures smart. Make your code simple and easy to understand. That's a lot easier for other people to pick up than the other way around. So all those cool tricks that you can do that completely obfuscate what's going on. They're beautiful if you're in a coding contest or if you're trying to show off. But if you're trying to build a community, you need code that's simple and understandable. And again, this is just the same as your users as co-developers, users, beta testers. They're the same thing. Treat them well, appreciate their efforts. If somebody submits an issue or a bug to you, you don't have to fix everything. You don't have to, drop everything to fix a minor bug, but you do have to be appreciative, and you should let them know that their stuff is appreciated, and look at it, right? Try to look at it. I once delivered a 5. So this last one is any tool should be useful in an expected way, but a truly great tool lends itself to users you never expected. I'm going to kind of go sideways on this one a little bit. I once delivered a 5-rack system of equipment. Did extensive training, including theory and practice of using the equipment. Left the site, came back. They were doing things in a tenth of the time that we had taught them, and they had turned off 3 of the racks. So you never know the ingenuity of people. Give them tools, give them things to use, and then give them the freedom to kind of figure out how to use it. And when you do, what you find out is that, what parts of your tool are useful, and just the amazing things that they can do with, 2 of the 5 racks of equipment you delivered. Yeah, syntactic sugar just makes things easier to understand. Again, we're moving towards, when you're doing stuff, do the stuff that makes it simple, that makes it understandable, that makes it sweeter for the consumer to consume. There are only 5 managements in software. Only 5 functions in software management. You're responsible, if you're managing your project, you need to define goals and keep everyone pointed in the same direction. And in open source environments, a lot of times that's a little bit like herding cats, right? You can't command somebody to do something. You can encourage somebody to do something. You can kind of coax them into doing something. But this is a hard job. Define the goals. That's hard. And keep everyone pointed in the same direction, because you're also not a dictator. Defining goals is not the same as saying my goal is the way to be. Open source development, if you're in a bazaar, it's really easy to miss details. Your job is to make sure that the details do not get skipped, right? Your stories, your agile development methodologies, your scrums, a lot of the details are going to be assumed. You need to make sure that they're actually getting executed. Documentation sucks. It's boring. Nobody wants to do it. But come back to an old project that doesn't have a good installation guide and try to resurrect it. Come back to one of your projects from your freshman year, if you're a junior or senior, or for some time in your high school years, if you're not, and try to resurrect it, and then try to remember what versions of all of the libraries you needed are actually there. I mean, remember, let's go back to my little thing here, right? I forgot to install, because it's not documented anywhere until you get the error, I forgot to install, well, come on. Latex MK. So I couldn't make our project. Let's see if it works now. One more I have to find. All right. I will do that after you guys are done. Well. All right. So that's important. A commit's a commit. A short code commit may be more important than a short documentation commit. May not, if the documentation commit corrects some unstated something or makes something much more understandable. But it's a lot easier to write documentation, to write blobs of documentation than it is to write blobs of code. So, do the drudgery, do the documentation, particularly when you're getting started or joining a new project. You're going to want to be reading the documentation anyway. Fix those errors you find along the way. You're keeping everybody pointed in the same direction, and you also want to make sure that not everybody is working on the same thing. So everybody's going in the same direction, but they're doing different parts of it. Having 5 people develop the same module and the first come wins is not necessarily effective unless you have a lot of excess people. And then finally, if you need resources, if you need to come to me for trying to find a way to do an AWS server or something like that, that's the other things you need to do, is you need to find the resources both in people, time, and goods. When you're establishing your open source project, create a clear vision, right? Know what you're going to do, how you're going to build it. Involve team-oriented people. Somebody who is brilliant but unwilling to work with others or unable to work with others is not necessarily the best teammate. You want to figure out, before you get to the point of everybody having a different idea on how the project's going to be run, you want to agree to it. Now, if you're starting a project alone, you can probably pretty much define that and then just allow in people who agree to it. But if you're starting it off with 2 or 3 or 4 or 9 people, you need to identify a management structure. You need an effective software process, which means are we going to use a blessed repository? We'll talk about that. Are we going to use a shared repository? How are we going to decide what code gets in? How are we going to decide what gets worked on next? All those things need to be kind of figured out. And then you want to have a communication protocol. How are you going to talk? We're going to use Discord largely in this class. I do have a mailing list, and this is kind of our periodic face-to-face meeting. You don't have to have all of these, but you do need to have some way that you're going to communicate. If you don't establish the core architecture early, then it's kind of hard to build anything else on it, right? So even a lot of projects, having one person build a structure that's going to hold the rest of the code, I call it a thread. A database, a server, a client. Establish that early. Get something for other people to add to and improve on. And you may have to start small with that. There's not necessarily a lot of people who can get their hands in on the same code at that small stage until you have enough of a framework that they can start hanging things off of it. I would like to see a test as early as your first minimum viable, as early as your first thread, right? Test the thread. You're going to be using Git, and it's always good to have a common language. Figure out whether you're going to use, Python and JavaScript, or you're going to use C# or C++, whatever. Get that locked up. Use external tools, libraries, etc. as much as possible, because it doesn't make sense to reinvent the wheel. You have something better you're going to do. You're going to turn them into something. Look for what's there, use what's there, and don't reinvent it. Finally, we will talk about licensing. We will have a module on licensing. You need to have a license. You'll know why you need to have a license. If you don't already, you'll know why by like the third class, the third week. But pick it and establish it. And then make sure that anything else you use is compatible. And we'll explain what that is as well. But, different licenses impose different requirements on you, and you have to make sure that if you use somebody else's library that you're allowed to, given what license you're using. And if you do plan on going ahead and making something out of this, making money off of this, which is allowed, encouraged, important. Think about, as you're developing, what that strategy might be. Are you going to be something like Adafruit, who basically sells a bunch of stuff that you can get anywhere in kits that are easy to put together, and you don't have to find out and buy all the parts, right? And then offers support. So if you're in a hardware realm, think of something like that. We're supposed to go till 2:10, right? And we are at 2:04. All right, I have another really short presentation on Linux. I'm going to hit that at the start of lab on Friday. It took me longer to go through this because I'm not getting any feedback, so I don't know if you guys are grokking it or not. But I'll go over the Linux section of this presentation Friday. Until then, you guys have any questions? Anybody have any comments, questions, discussion? Want me to clarify something? Want to send out cookies to everybody in the class? Chocolate chip would be good. Nothing. All right. In the absence of anything else, I'm going to let you guys go. Again, I'll pick up. I think that Linux thing is about 10 slides. It just talks a little bit about the history of Linux, because you should know that. But I'll pick that up on Friday just before lab, and then we'll go into our lab. I don't think you'll have a lot of problems with the lab this week. All right. We will see you guys on Friday for installment 2 in the lab. There will be a lab due after Friday, or we will do a lab on Friday.